Hello everyone, Anthony here with another video. I know I've been away for a couple of months now, but I needed to do some in real life stuff. But I'm back and I'm back better than ever. I'm gonna do a complete rebrand of the channel and we are going to do a lot of amazing stuff, all blockchain related, all crypto related, of engineering of course. I did not forget the blockchain from scratch series. A lot of people are asking me, when is the next episode coming? Well, I have some fucking good news. It's coming right now. And what we're gonna do is, I was thinking, what good content can I make for the next episode? Because it was a little bit boring here and there, but we needed to do those stuff before we can actually do the fun things. And we are going to make our own virtual machine from scratch. We're gonna implement it into our blockchain and we're gonna run code, decentralized, distributed, all the good stuff. And we're gonna do it right now. So let's get into it. It's been a long time that I actually visited my own code, so I'm gonna do a git log just to check where we ended. Look at this, it's July 13. Added block encoder, decoder, and implemented broadcast blocks. Well, cool. The next thing, what we're gonna do is, first of all, let's make sure we can, our tests are running, and make run to see. Yeah, it's all working just fine. That's cool. That's very cool. All right, so virtual machine. Yeah, so basically, what is a virtual machine and why do we need it? So if you think about a blockchain is nothing more than a distributed, decentralized database. Everybody's overcomplicating it, but at its core, it's just a database that is running in a decentralized environment. So if we have a state in our database and we want to adjust the state, then we need to have some kind of a deterministic function that is running on all the machines, and it has some consensus on it, but that's something for later on. So what does a virtual machine do is basically simple. It takes state A, it runs code, and it transforms it to state B. And that's all it does. And how you implement that VM can be a very broad aspect of things you can do with it, but we're gonna make it very simple at start because that's my principle of doing things. You make it very simple, then you improve it, and then you make it faster. That's what we're gonna do. The main thing we need to find out is, where do we place this beast? So let me check. Wait, let me quickly adjust my screen because I basically moved everything into a new space. You see, it's lighting. I have this whole, I'm basically I'm a professional right now. It's amazing. All right. When the question is, where is the perfect place to put this VM? And I think if we go into blockchain, we can go to, where is it? Add block, right? So this is the function that adds a block. Maybe we can check the server to demonstrate this a little bit more. What's going on? Process message, and you can see if the message is a block, we go into process block, and that's basically process block. Let me find it. Here is this one. We calling our chain, and our chain adds a block, which is basically this function. And we do our validation here. I'm just trying to put these things back into my brain because it's a long time that I visit this code. So it's going to be a little bit of hacking my way around this code base. So we do our validation, and after our validation, we add a block. So basically we persist it. And in here, we can run our VM code. So what can it do? I had something in mind. For example, we do VM, bc.vm, or basically bc.new VM, something like this with, wait. We do for range B for transactions, like for each transaction in this block, we are gonna call a new VM with takespin data. And then we're gonna do something like, for example, this is all pseudocode. VM is basically this, and then we say VM.run, and we call it a day. And if this returns an error, we cannot apply the state. And if it does not return an error, then we can apply the state and call it a day. So that's what we're going to do. But first of all, I'm going to be a little bit rusty. I'm not going to lie. But it is what it is. It is what it is. So what we're going to do is we are going to create a new file, call it vm.go. And we also, wait, let's, it's going to be package core. Maybe we could do it in our own VM package, but for the sake of this. All right, cool. Let's close this. All right, I did not prepare this like usual. This is my way of teaching. I'm just doing it all on the top of my head because then you can see how I think, you can see how I do things, and it's going to be garbage at first, but you're going to learn so much more than looking for a simple tutorial that basically copy-paste everything and you get cheap dopamine, but you are going to keep being trash. And this channel is only for the best of the best, okay? So we're going to do type VM. It's a struct. That's what we know. Then we're going to say a function, new VM. It's going to take in data, which is a byte slice, and it's going to return a pointer to our VM. What the hell's going on? Yeah, like this. So we're going to say return VM like this. Wait, first of all, I'm going to settings. Is this better? This should be. Maybe 13. That's maybe too big. Holy shit. That's too big. 12. That's the best I can do. It's the best I can do. So we're going to return a new VM. A pointer to a new VM. Yes. Yeah, oh, cool. So what we're going to do, it's going to have data. So what our transaction has data. And let's open up transaction. Transport. Transaction. Yeah, so our transaction is going to have data, and this data is going to be, in our case, is going to be arbitrary code that runs on a VM. So we're going to load this code into this VM. So we're going to say this is going to be a byte slice. What's going on? Typing is a little bit scuffed. So data. So we say it's going to have data, which is the data. We're also going to have what we call an instruction pointer, IP. And it's going to be an int. And an IP, an instruction pointer, is basically, it points to where the current instruction is in the code. We also need, we also need a stack, but that's for later on. EP is going to be 0. IP, and then we're going to say, VM run. For now, it's going to return an error, I guess, which is for let me think. VM. We're going to say instruction is going to be VM data, VM.instruction pointer. That's our instruction. And then we're going to say our instruction pointer, we're going to increment this thing. And then we're going to say if our VM.instruction pointer is bigger than VM.data, VM.data, the length of the VM data, I think -1 on the top of my head. Then we're going to say break, and the code is done, okay? What we can do is do something like print this instruction just to make the compiler happy. And then in this case, wait, we're going to return nil. Then we're going to open this. Wait, what's going on? I forgot my key bindings. B, yeah. Then we're going to say VM test go package core boom func test VM t testing t like this, boom boom. Man, Visual Studio Code is lagging. All right, so we're gonna say VM is gonna be, first of all, we're gonna make a data. It's gonna be a slice, come on, slice of bytes. Let's say null x1, 0x2, and 0x3, something like this. And then we're gonna call a new VM with the data. And then we say VM run like this, test. All right, so that's the first thing. We already have something running, isn't it amazing? So what we do is nothing. We do literally nothing. So I'm thinking what I need to do as next step. It's all the way a good starting point is. So basically we are reading in our transaction data, then we are looping over it. We increment our instruction pointer and we say if the instruction pointer is higher than our data we have in our code, we need to stop. Of course, otherwise we will keep looping and that's no good. Yeah, okay. So to make it very simple, we are going to make a couple of two instructions. We are going to just make some script that can add two integers together. I think that's a good starting point, and we can build and iterate over it and doing all that good stuff. So first of all, we need to have something that is called an instruction. Instruction is going to be a byte, and then we say const instruction push. It's going to be an instruction. Okay, very important to know. We are going to allocate some, we are going to define some instructions, constants. The problem is, what is an instruction? For example, add, sub, diff, mul, that are all instructions. Increment, something like that. So, but we cannot use, for example, null x1, 0x1, because that's, we have, for computations, we have all the numbers from 0 to 9. That's reserved because that's actually the integers itself. So we can start our instructions opcoders, or whatever you want to name it, from 11 or 10. We could say B. That's 11, I guess. And if it's not, please correct me. But I think it's 11. I think this is 10. Let's do it like 10. It doesn't matter. All right. Push. Then the next thing we need is instruction add. An instruction. And it's going to be 0B. It's going to be 11. Okay. Why do we need instruction push? Well, I'm going to explain you. So let's say we have the number. Let's say we want to do this. We're going to write some code, and the code is going to be 1, 0, 1 plus 2 is going to be 3, right? That's the code we're gonna execute on our VM on every machine, and you will see it later on. What do we need to do is we need to say 1, then we need to push it on the stack, then we say 2, then we say we need to push 2 on the stack, then we say add, which basically is 3, and then we need to say push to stack. That's basically what's going to happen. And then it's on the stack, and if it's on the stack, we can read it. All right? So we need a stack. Okay, you can make a stack super complicated if you want, but we're going to make it super easy. And we're going to say a stack is just a slice of bytes. And then we can say that the stack, we can pre-allocate some memory. It's going to be a slice of bytes, let's say something like this. And then of course, if we have a stack, we need to have a stack pointer, which is an int. Instruction pointer. Say stack pointer. Typing is not on par, but that will come. Stack pointer. For the stack pointer, I'm gonna do something different. I'm gonna say it's -1. And the reason for that is you will see later on. All right, so let's write the program. So we want to do 1 + 1 = 3. So what we do is we say 1, 2, 1, push. It's going to be 0, 0x a. All right. So we say 1, push to the stack, 2, push to the stack, and then we say add b. That's our program. So let's quickly run this thing. All right. All right. I'm thinking. Okay, let's make let's say VM. Let's say VM exec. It's going to be instruction. Switch instruction. Case. Instruction push. We do this. Case add. People are sending me messages, man. Getting distracted. All right. Let's do. We're gonna say if I'm exec this instruction. If the error is not null, we're gonna return the error. And of course, it's complaining because exec requires an instruction and we are giving it just a byte. So what we could do, because it's the same thing, it's the same type, it's the same underlying type, we could just do this and it's all working. Wait. How far are we in this recording? 18 minutes. We chillin'. All right, so. All right. What we're gonna do is we're gonna keep running this thing. Let me see if this is working actually. Yeah. So we're gonna do this, and each time it comes into the push instruction, you're gonna say, let's make a function, VM. You're gonna call this function push stack b byte, I guess. Yeah. VM stack. Equals b. And I think we need to increment the stack pointer right here. Not sure. What's going on? Big errors. VM pointer. Okay, so push stack is basically simple. It takes a byte and we're gonna increment the stack pointer, and then we're gonna say, hey stack, put this variable inside this slot, current slot, where the stack is currently. So if it's push, we're gonna say VM push stack. So we're gonna push the stack, but we cannot, we need to do VM data VM instruction pointer -1. I think. Push stack, push stack. Print F, I guess, and then we can say something like this, and do VM data. No, VM stack. Let's dump the stack real quick and see what's going on. Yeah. Oh shit. What's going on? All right. This is crazy. Yeah, it's doing. I'm an idiot. All right. Okay, cool. So this is working. So this is our stack, right? This is a stack, and we pushed the value 1 and we pushed the value 2 on the stack, and all these other things just empty pre-allocated memory. So don't worry about that. All right, so that's working. So then the next thing we need to do is, if it's an instruction add, we need to say that A, and this is a very, very, very simplification of a virtual machine, but we need to start somewhere. If you wanna learn something, we need to start very simple, and we can make it so complex as we want. Yeah, back to business. A. So okay, we push 2 values. So if we have an add, if we come across an add instruction, we know that we should have 2 values on the stack. Now we need to, what I can do, I'm gonna do something like this. VM stack 0. Depends if you are going to flush a stack, yes or no. So a lot of optimizations can be done, and this probably people that's gonna see this gonna say, hey, yo, this is not good. But I know, but wait and see. So value B is gonna be stack 1. Then we're gonna say C is gonna be A, B. And normally you cannot do this, because if you're reading bytes, you first need to convert them into an integer. But this is Go right now, and it all works out of the box. But this is not the best approach. Normally you should work with big integers and such, because yeah, that's for later on. C, A plus B, and then we're gonna say VM push stack. So we have this is gonna be 3 basically in our case. And then we're gonna say push stack, and we're gonna push this C, which is actually an int. But yeah, whatever. It's magic. It's just magic. So we're gonna push C to the stack. And that's it. And that's fucking it. So let's test this. Yeah, so that's exactly what's happened. So we have 1, 2, and 3, which is exactly what we want. So now we can make a test for it, and we can say, okay, we run this VM, and let's say assert no. This cannot return an error, and then we say assert equal. It's going to be, I think, byte 3. the last thing on the stack. So normally you could make like a data structure, a stack data structure where you could call pop and next, first, last, pop, whatever, would make it easier. But for now, I'm gonna say the stack SP something like this and see what's going on. All right. Didn't expect this actually. Let's do 4 and see if this is amazing. Hey, so it worked. Cool. I'm laughing because normally this, yeah, sometimes life gives you lemons, man. Sometimes life's good. It is what it is. It's working. Nice. Cool. So you can see we can do this with other numbers, right? So you could say, for example, we do to push add. So this should be 4, right? Cool. So nice. The next thing is we go to blockchain. Oh man, this makes me so happy, I'm not gonna lie. You see, programming gives you, if you can do those simple things, right? It gives you instant dopamine, instant serotonin, instant reward. It's insane. It's the best thing you can do. So I could make this super complicated with stack, with complex stack structures and oh man, all these crazy conversions and whew. But then my head would be full of those complex things and I would not be happy, you know? Yeah. Add block. So what we're gonna do, oh shit. You know what? We're gonna pre-allocate the VM. We can make it better. So we're gonna say VM is gonna be a new VM. Like this. Wait, for TX. Man, my typing is not on point. B transactions. I'm gonna say TX when data. It's gonna be this VM. Run. Like this. Maybe catch the error, because if there is an error, we cannot apply the state. Return error. Boom. Maybe we need to do some login. We could do BC logger log executing message executing code, and then we can say the hash of the transaction is going to be tx hash, and then of course tx hash like this. Let's see. I think we can run into some problems because our data we had for our transactions. Let's go to main. You can see what I mean by this. We create some random garbage. You see, new transaction, and this is going to be some random data in it. It is what it is. So it's probably gonna fail. I'm thinking what to do next. So I could actually already make run this and see what's gonna happen. Yeah, so it's running the code, right? So that's good. And of course, our late remote is complaining, but it is what it is. It doesn't matter. It's because he's late. And that is deserved thing. Thing that I want to do is, if you go to VM, I'm gonna delete this logging. this instruction. I'm gonna do this, and then what we could do is executing code. You could say len takes data, something like this. Okay, so it's executing code and the length is 9. So what we're gonna do is VM stack. The problem is this is a bad practice, but just for the sake of this thing, VM. What do we do here? VM stack. Yeah. So what we're gonna do is say VM stack VM SP. VM result. Okay, we're gonna do it like this. We're gonna print out the result of the virtual machine, and instead of doing this garbage thing, we are gonna make what's going on? Like this. We're gonna say this, boom, delete this garbage, and we gonna feed in this data. And if everything goes well, guys and girls, or something in between, you need to be careful these days. If everything goes well, this should return. Everybody in this network should say this for. Okay, so let's go. Make run. Yeah, everybody is agreeing. You see? Everybody has calculated 4 without any error, so we can apply the state, but this is just a simple example. But yeah, so that's cool. The next, what we're gonna do next, I think this is a very good thing to wrap up. This episode is 33 minutes, which is perfectly fine because your attention span is already long gone, I know. But what we can do is next episode, we're gonna make it a little bit better, a little bit more optimized. And we are going to add more things, and we are going to implement the state. That's very important because we cannot add balances. We cannot store anything. So the VM, what kind of purpose has this thing? Because we have no state. So we're going to implement the state. Then we're going to run our VM with some cool code, and then we're going to modify the state, and it's going to be insane. Thank you guys for watching. Please don't forget to like and subscribe or to put something in the comment. It really helps me. Get this video to a lot of people, and you know all that stuff, right? So that would be nice. Like and subscribe, and yeah, ring the notifications bell because I'm gonna drop so many good videos, especially around blockchain related stuff. We're gonna do some DeFi protocol engineering later on. It's gonna be amazing. It's gonna be Gucci. Yeah, thanks for watching, and see you in the next episode.